Green energy to fight climate challenges, Part 1. Today climate change has created big problems for the entire world. World is trying to find out the plausible solutions for increasing challenges and its resultant impacts in an urgent basis. The solutions that are being looked into would have to provide comprehensive overview of the global energy landscape, emphasizing the urgent need to transition from fossil fuels to renewable energy sources in order to combat climate change and protect the Earth's fragile ecosystems. At the heart of the climate crisis lies energy production, which is responsible for a significant portion of greenhouse gas emissions. Over 75% of global greenhouse gas emissions and nearly 90% of carbon dioxide emissions come from burning fossil fuels such as coal, oil, and gas. These emissions trap heat in the atmosphere, accelerating global warming and threatening environmental stability. To avoid the worst impacts of climate change, scientific consensus demands that global emissions be cut by nearly half by 2030 and reach net zero by 2050. This imperative has driven a global shift toward alternative, renewable energy sources. Despite the current cost-effectiveness of fossil fuels, the long-term environmental, economic, and health benefits of renewables make them a more sustainable choice. Key reasons for this transition include climate change mitigation, energy security, and cost competitiveness. Renewable technologies like solar and wind have seen dramatic cost reductions in recent years, making them increasingly viable alternatives. Moreover, unlike oil and gas, renewable sources are not subject to volatile price swings influenced by geopolitical tensions. Beyond emissions reduction, renewable energy offers additional advantages such as improved air quality and job creation in the clean energy sector. The world is now actively working to phase out fossil fuel dependence and adopt cleaner, more sustainable energy systems. This effort is also closely linked to the recovery of the ozone layer, which protects life on Earth by absorbing harmful ultraviolet, UV, radiation from the sun located in the stratosphere. This layer began depleting rapidly in the late 20th century due to ozone-depleting chemicals, prompting global alarm. In response, the United Nations spearheaded critical international agreements. The 1987 Montreal Protocol marked a turning point by phasing out nearly 99% of ozone-depleting substances. This success laid the groundwork for broader climate action, including the UN Framework Convention on Climate Change, UNFCCC, the Kyoto Protocol, adopted in 1997, effective in 2005, and the landmark Paris Agreement in 2015. The Paris Agreement, ratified by 196 countries, commits nations to limit global temperature rise to well below 2 degrees Celsius, ideally 1.5 degrees Celsius, compared to pre-industrial levels. Thanks to these coordinated efforts, the ozone layer is on a clear path to recovery. Scientists project it will return to 1980 levels before the ozone hole emerged, by 2040 in most regions, 2045 over the Arctic, and around 2066 over Antarctica. The Antarctic ozone hole, though still present, has been gradually shrinking since 2000. However, emerging geoengineering proposals, such as stratospheric aerosol injection, SAI, to reflect sunlight and cool the planet, could have unintended consequences on ozone chemistry, stratospheric temperatures, and atmospheric circulation. These risks underscore the need for caution in deploying large-scale climate interventions. Meanwhile, global warming continues to pose a serious threat. From 1990 to 2005, human-caused greenhouse gas emissions rose by 26%, with carbon dioxide accounting for 80% of this increase. Major sources include power plants, 40% of U.S. coal emissions, mostly from coal, transportation, 33%, industrial farming, releasing methane and deforestation, fertilizer use, which emits potent nitrous oxide, oil and gas drilling, permafrost thaw, releasing vast amounts of trapped carbon, landfills, producing methane, and even volcanic activity, though its impact is minimal and temporary. Global energy consumption is immense, approximately 580 million terajoules per year, equivalent to 13,865 million tons of oil. On average, each person uses about 57.6 kilowatt-hour daily, though consumption varies widely between developed and developing nations. Energy demand continues to grow at 1–2% annually, driven by rising populations and economic development. This growing demand makes the transition to low-carbon energy more challenging, as new clean energy must not only meet rising needs but also replace existing fossil fuel infrastructure. Renewable energy derived from naturally replenished sources like sunlight, wind, water, and geothermal heat offers a sustainable solution. Though humans have long used wind and solar for basic needs, the industrial era favored cheaper but polluting fossil fuels. Now, advances in technology and declining costs are revitalizing renewables. They already account for over 12% of U.S. energy generation and are expanding rapidly worldwide, from massive offshore wind farms to rooftop solar panels. The main types of renewable energy include hydropower, the largest globally, led by China, Brazil, and Canada, wind, with global capacity increasing 22-fold from 2001 to 2017, solar, which saw a 4,300% rise in capacity from 2007 to 2017, biomass, geothermal, and ocean energy, still in early development. Solar energy has seen the highest growth in new capacity from 2018 to 2022. Solar power, which converts sunlight into electricity via photovoltaic panels or uses solar heat for steam generation, works best in sunny, low-latitude regions such as Pakistan, Afghanistan, Iran, and the Arabian Peninsula. However, it is intermittent, requiring energy storage solutions like advanced batteries to provide power at night. Wind energy, harnessed through turbines, is also expanding rapidly and complements solar in many regions. In conclusion, the present efforts focus the critical importance of shifting to renewable energy to mitigate climate change, protect the ozone layer, and ensure a sustainable future. While progress has been made, continued innovation, policy support, and global cooperation are essential to fully transition away from fossil fuels and build a cleaner, safer world.